Good afternoon, everybody. I'm Sean Mallon. I'm the sales manager with Spirac. The webinar today is really just to give you some idea of how to select a screen for a suitable application, and there'll be some examples of screens following. So let's start. Let's go and with some basics. What is a screen? Well, a screen is a large filter to capture and remove debris from any oncoming flow. And what types of screens are there? Well, the screens are really divided into two groups. So there's coarse screens and fine screens. Coarse screens are 1D screens, fine screens are 2D. And coarse screens effectively protect fine screens from large debris in the flow. And the fine screens will remove smaller particles, usually sort of 3 to 6 millimeters, two-dimensionally to protect a process downstream. So that's essentially the difference in the two screen groups. What's the difference between 1D and 2D screening? Well, 1D screening is where you utilize a mat. So that's a buildup of debris on front of the screen. And there are a series of steps that move up and down on the screen, moving that mat further to the discharge point. The disadvantage with 1D screening is that it can allow thin ribbons of material to pass through. So even though you might have 5 or 6 or 10 millimeter spacing, anything that's long and thin and less than that will potentially pass through the screen itself if there's no mat in place or that mat has been dislodged. Whereas 2D screening will capture any debris which is larger than the perforation, and it achieves a high capture ratio of up to about 89% for 3 millimeter perforations. 2D screening has actually been the preferred method in the UK since the late 1990s, and there are very, very few 1D screens left in the UK, although of course I'm aware that that technology is used in other countries, of course. Having said that, for a similar channel width, a 1D screen will pass a higher flow and have a lower head loss than a 2D screen, and this is because you're not restricting the flow as much with a 1D screen as you would do with a 2D screen, but there are ways around that. Okay, so design considerations, and what do we need to think about when we're designing a screen? Ideally, the maximum flow through a 6 millimeter perforated screen panel should be no more than 1.2 meters per second. And the reason for that is that if you have higher flows, velocities than that, you can or there is a risk of it extruding the debris through the panel and then it being carried downstream. So ideally, that's the reason the screen is there, to prevent that from happening. So if you can limit the design to 1.2 meters per second by selecting the correct width of channel and the correct perforation size, then that's ideal. For 3 millimeter perforated panels, it's usually less than 0.9 meters per second because velocities higher than that will extrude through the small perforations. Or sometimes the client has his own specification, but generally we work to 1.2 meters per second as a rough guide for 6 millimeter. In front of the screen, of course, you don't want the flows too low, or velocities. So you try and design the screen and the channel so that you get a minimum of 0.4 meters per second. This will allow or prevent any settlement of grit or large debris in front of the screen, and then encourage it to be either passed through or be captured by the screen itself. If we're providing a fish removal or fish recovery type screen, which we can do, of course, not just for removing sewage, but actually putting fish and keeping them alive and putting them back into the watercourse, then ideally you shouldn't exceed 0.25 meters per second for the screen velocity. The reason for that is just so that you don't injure the fish. When you're calculating the size of a screen, based on we always do that based on a downstream water level. And the reason for this is because if you know what your downstream water level is and the rest of the works needs to drive it hydraulically, that coupled with the head loss, we can then determine what the upstream water level is and ensure that allowing for a freeboard of 300 millimeters, the flow is going to overtop the channel upstream when you put that screen in place, and it's running at its 30% blinded or whatever the specification is. It's important, obviously, that you don't flood the work, so that's why we always base it on a downstream water level. Our competitors, I am aware, do the other way around, but we feel it's more whilst a little bit more conservative, it ensures that the works is correctly designed and you don't result in any sewage spilled upstream. For new installations, subject to high solids content and high flows, particularly if you've got sewer pipework connected to a storm drain, storm sewers, then you often get a first flush build up, so that you, over a long period of time, you can get debris collecting in these storm sewers, and then when you get a rainfall, a heavy storm, that all gets then washed down into the sewage works. For high flows, and if you've got large debris in there, sometimes tires, large bits of wood, all sorts of things can perhaps damage a fine screen because they're not delicate, but they're not as robust perhaps as a coarse screen would be in that application. Then we always recommend installing for coarse screens. And then for new installations, and this isn't always possible, again, because of limitations on footprint on site and available space, but ideally you would like to have a channel length in front of the screen, and it should not be less than 4 times the width of that screen. So if the screen is a metre wide, for example, ideally then you'd want 4 meters in front of the screen of clear channel, so that allows the flow to settle to a laminar flow to present to the screen, so that you then get the maximum capture ratio. Further design considerations. For designing new installations, design parameters determine the upstream channel velocity is lower than a recommended minimum of 0.4 meters per second. Then you can reduce the width of the channel upstream and downstream, so that you can actually increase that velocity. And I'll show you how that can be done in a minute with a couple of examples. Also, you can add a step in front of the channel, in front of the screen rather, to aid the flow. You could also put a parabolic curve or benching in the channel in front of the screen to further increase the velocities. For an inclined screen, normally we angle these at between 70 and 75 degrees. 75 degrees is the maximum, because what you don't want to do is allow the screening mat or the debris on the screen that you've captured to then start to roll back into the channel flow. So anything more than 75 degrees, you can get that problem. We do have a method of preventing that to a certain extent, which I'll show later, but that's really is the maximum angle. Of course, because it's at that angle, this means that the screen will be its shortest overall length, because there are fewer panels required because of the angle, or grid length, for example, and therefore you get a lower cost for the overall screen. So when you're thinking about not only the screen design, but also the cost of the project, that's really a good starting point to make sure that you can design the screen with an angle of 70 to 75 degrees at the first instance. Sometimes on site conditions determine that you need a lower angle for the screen. That may be because of you've got several screens side by side and they're very close together, so you want to have one at a higher angle and one at a lower angle that's next to it, so that you can then get access to drive shafts and remove gearboxes, an example. This also might be because of the screen's handling or the launder system you've got downstream. So that's also acceptable. We can go down to about 45 degrees to angle the screen. When you do that, though, that also means that it lowers the screen velocity in front of the screen, because you've got more submerged panels preventing the flow getting through. So as a result of that, you need to then think about how you design the channel to increase that velocity. Also, one thing to consider is, because if you've got a 45-degree screen, this means the screen will be overall will be longer to get the same discharge height. So there'll be more panels required for the screen, so it'll be more expensive. So again, that's something to consider when you're designing the screen system. The screen inclined at 45 degrees will pass more flow due to its increased submerged screen face length, but as you can imagine, with a screen that's at 70 or 75 degrees, the perforations in the panel are more or less circular when presented to the flow. as you decrease the angle of the screen, that appearance of that perforation that goes from a circle to an ellipse, effectively. So that actually will impede the flow somewhat, but generally speaking, you get about a 12% increase in the flow compared to a 70-degree screen. So if you are struggling with a certain channel width that you need to put a screen in, and a 70-degree screen won't pass the screen velocity and the flow, you can increase it to 45, and that will hopefully give you the parameter that you're looking for. So I mentioned earlier about how we design a screen channel. This is just an extract from our design guide. So I've selected here a channel 1 meter wide and a channel depth of 1.4 meters, a 70-degree screen. And you can see here the flow rate is 260 meters cubed per second, or 260 liters per second. This, with this channel dimension detail, gives you a screen velocity of 1.19 meters per second. So of course that's ideal. That's just what we're looking for, not greater than 1.2. However, the upstream velocity is 0.24 meters per second, so lower than the recommended minimum. To get around that, we can decrease the channel width in front of the screen. So you're still at the screen, it remains a meter, but in front and behind it's 0.6 or 600 millimeters. And that brings the upstream channel velocity up to 0.41. So there you've got over the problem of the upstream velocity. You've got the ideal screen velocity through the screen, and you've got the ideal screen design for that flow with the minimum channel width and depth. So that would give you, on a new installation, the ideal screen selection. So some screens, what are we talking about? What are core screens? Well, there are two types of core screens we manufacture. There's the multi-guard and the rake guard. Taking each one in turn then. So the multi-guard is a series of grid bars which are arranged on the screen, and then there's some multiple rakes which rotate on a rotating band or chain, which is driven by a sprocket and motor. This type of screen usually installed in wastewater sewage works, of course, pulp, paper mills, seawater and pumping station application and intakes. Usually the screen's inclined at 75 degrees. It can be as steep as 80 or as shallow as 35. The reason it can be as steep as 80 is because of the carrier beam that does allow large debris to be collected and passed up. The channel sizes can be up to 4 meters and wide and 12 meters deep. So these are big screens, and we've installed many of these in Hong Kong particularly. High screens loading due to the multiple number of rake passes. And you can start from a bar gap of 5 millimeter and above. So if you're core screening, you're protecting MBR screens, for example, which are sort of 1 millimeter and less, or you can then put in these 5 millimeter gap core screens if necessary. Rake travel speed, usually 6 meters per minute, but you can make it dual speed just to make it faster for particular high flows and high volume rates of screenings. You've got a multi-rake function, so it's collecting more screenings as for each pass. There's a reversing wiper facility at the top, which actually allows any debris that's caught at the top to be removed by the rake as it passes as well, so that prevents a build-up on the back of the screen. There's no wash water required on this type of screen as well, so other than the drive, you don't have to provide any other services to it. Sometimes, and a little bit more detail I'll show, but the bottom sprockets are required to hold the chain and drive the chain in place. Those are usually required for specific markets there in the US or Hong Kong. So if I just show you a little video of how this thing works, and then you can see exactly what I mean about what a Vanguard operates like. Sorry, chain guard, multi-guard. So you've got these multiple carrier beams with these combs which engage in the grid bars here. This is obviously lying on its back, but imagine this was inclined at 70 degrees. As these combs come round and the screen chain is rotating these carrier beams, they will engage with the grid panel at the bottom, as you can see as it comes round. So the flow is coming from top to bottom, if you like, through. And then the debris will collect on the rake, the grid bars, and these carrier beams will then remove that debris and take it to the top of the screen for discharge into screen's handling. So as you can see, very nice, robust, solid design. The bars are usually tapered so that the wider at the front than at the back. This just prevents any debris locking on the carrier combs as the combs pass through. So it just provides effective cleaning. Sorry, I lost the. Oops. Right. Okay. So I mentioned the bottom sprocket. Normally, the chain and the carrier beams are held in this guide here on the side of the screen, but if the specification dictates, we can put this sprocket on the bottom on a stub shaft. This shows the flip wipe at the top and the carrier beam construction on a solid chain there, which is heavy duty chain.
Sham, sorry to interrupt you there for a second.
Mm-hmm.
I can't see the presentation.
Just a minute.
I think no one can.
Oh, okay.
That's all right.
That's all right. I think I've started from the. Bear with me. Sorry, everybody.
Good old share screen button.
Yes, there we go. Okay, sorry, apologies. So let me just go back and.
Oh, word.
Let me get to. Okay, yeah. So the chain is there rotating in the bottom of the screen and encased in this guide here, which is a ultra high molecular polyethylene, which helps guide the chain around, so you have no wet moving parts at the bottom. But as I said, you can get a sprocket in the bottom there also if the specification dictates. But the problem with that is that you can get some debris grit building up on the bottom here, so it does cause a wear, but that's the specification sometimes that's required for various markets. This shows the flip wipe at the top, so as the combs rotate around the band on the chain, this flip wipe mechanism at the top of the screen wipes these carrier combs and removes the debris. And these are the typical spares that we would provide for this type of screen. The other type of core screen I mentioned is the rake guard. So this is a very good, robust type of screen. It comes more in kit form rather than a fully assembled screen like the chain multi-guard. Excuse me. Key features and points for this: generally wastewater installations and sewage applications. Again, 75 degrees. Channel sizes 3 meters wide, 5 meters deep. Not so large as the chain, the multi-guard. But nevertheless a very robust screen. Gaps usually 10 millimeters and above. Similar construction in terms of the tapered bar. It can take up very high flows, up to 2,500 liters a second. And the rake speed, so this rake here is engaged by an actuator, so that when the rake gets down to its lowest point, an actuator engages the rake on the grid bars, and then it will move up at 10 meters per minute, and then on the downstroke it will move down at 20 meters per minute whilst it's not engaged, just to allow the screen to re-rake the grid bars more quickly. Very high screen's discharge capacity and low hydraulic hard loss and no wash water requirements. So and then as I mentioned, this electric actuator to engage the rake. Now when the screen is not cleaning, actually everything is arranged at the top of the screen out of the flow, so you're not getting a buildup of debris on any of the rotating parts. So as I mentioned, this actuator here is what engages the rake, and there's a chain mechanism here which allows it to lower as the screen's operating. And this just shows some pictures here of what this actually looks like when the chain is gathered up here at the top and the rakes are at their highest position. Obviously there's a penstock in front of the screen there, just isolating the flow, but you can see how that screen might be installed there. Typical spares would be the chains and any wear plates and this kind of thing, which of course we can provide. Fine screens then. So we've talked about the coarse screens. Fine screens, what are they? So we've got a range of fine screens, Vanguard, Drumguard and Vanguards. I'll go on to explain a little bit about the difference between the various different types of screen. Vanguard is the inclined screen I was talking about earlier, normally 70 degrees, 75 degrees, it can be 60 or 45. Key features of this is an escalators type screen, which you're probably more familiar with that terminology. Has a low head loss due to the side plate profile, which again I'll explain a little bit as we go down. The panels are one piece, they're normally sort of 3 millimeters thick, and the perforations will be 3 to 12 millimeters depending upon the specification. Flow ranges from 40 to 2,500 liters a second. All the screens in this type in the UK, they have to be certified at Chesterfield Street, which is a national screen evaluation facility. Our screens, when tested, actually performed top in class compared to other manufacturers. So we had a capture ratio of 89% for 3 millimeters and 81 for 6 millimeters. Usually specifications ask for sort of 75% or more. So you can see we clearly exceed that with our design, and there's a few unique features that allow us to achieve that. Again, we can be single speed or dual speed. Now, this type of screen is cleaned by a rotating brush. Again, I'll come on to that in a minute, but it's self-adjusting. And then there's a wash water to actually spray the panels further down. And we have what's called a washing debris plate as a standard feature also. Again, I'll come on to that in a minute. And then we've got modular section for the cleaning brush segments, which means that you don't have to stock long sections of brush in stock for a given width of screen, because they come in a standard modular size. They can just be put together by means of engaging them with it. There's dogs in between each section, which allows it to make a full brush to suit the width of a given screen. And then there's a static brush at the bottom of the screen there to prevent any debris from passing underneath it. So how does this work? You've got the screen velocity, the velocity of the channel coming straight through, presenting it straight onto the screen. There are cutouts in the side of the screen at the back here, which I mentioned. So instead of the flow passing through this panel, set of panels, and the ones behind, actually flow also passes through the sides, which then allows the head loss to reduce. That's a key feature of our design. If I just show you again a little video of how the screen works, and then get a better idea of the operation of it.
I think we have no sound.
No, so I turned the sound off, Peter, just because I just wanted to talk over it. That's okay. So again, you can see the debris collecting on the panels here as the band is rotating upwards. That carries it up to the brush, which is at the top. So all the debris is nicely collected on there. Bearing in mind, we've tried to maintain that channel velocity and the screen velocity to those parameters I suggested earlier. Again, we're just going through how wide these screens can be and how deep. So, you know, the sizable screens and the different perforation sizes that we can have. So it's important to remember that this is a brush cleaning screen. So as I mentioned previously, that these brushes actually come in segments which are about 100 mil wide, and they connect together on the shaft to make a brush the full width of the screen, depending upon what that is to suit the channel. And then there's a spray bar behind, which then washes also the debris off the back of the panel into the discharge chute, which would then feed into a screen handling unit. All the chain runs in a ultra high molecular polyethylene chain guide, and the chain is stainless steel or mild steel, or can be duplex depending upon the application, as is the construction of the screen itself. And this just shows this type of screen, and actually this is a large off-site build packaging that works we did for Yorkshire Water here in the UK, where we supplied the whole of this structure here, including the grit removal and the screen's handling and everything else. So that was a nice project. Okay, so let's just go back to the presentation. Okay. So as I mentioned, and you saw in the little video there, this is how the brush rotating in a clockwise direction, as the band is rotating counterclockwise to flick any of the debris off the screen's panel. This will then drop onto the discharge chute here. And then we've got the spray bar also, in addition to force any debris that's still clinging to the panels and wash that down into the outlet. I also mentioned this washing debris plate. This is a key feature because on other screen manufacturers' design, you can get a lot of screenings building up on this plate here. So consequently, there's a lot of maintenance required by the operator to keep removing the back covers and removing this debris, which can block. Sometimes it can drop down then and be carried further downstream. So we've developed this washing debris plate, which every so often sluices this plate with water, which comes out of these slotted holes. And then that allows the debris to fall into the launder, conveyor, or screens handling unit you have underneath, which is obviously a key safety feature because you've got reduced operator intervention. The spray bar is removable, so you can easily change or unblock the nozzles. We've got this cassette type arrangement here at the bottom of the screen to prevent debris from being carried underneath, and that's easily replaced. It does require access into the channel to remove this and replace it, but that obviously can be planned maintenance because it's not something that wears very often and can be readily done once you've isolated the inlet and outlet penstocks. And then, of course, because the screen is made to a certain width to fit an application, a certain channel width, then we have to put a sealing rubber either side of the screen frame, which then seals onto the channel wall, which runs down either side. Panels themselves, robust perforated plates, which is then formed into a self-contained panel. These are easily replaceable and just can be unbolted from the chain by removing some top covers. So it's not necessary to remove all the panels or all the chain, for example. You can just do these one by one if there any get damaged. I think I also mentioned when you've got the screen inclined at 70 or 75 degrees, potentially you can get debris falling back or large debris not being picked up in the channel. We put these elevator combs in pairs on every 5th or 6th panel. This actually prevents what we call rag rolling in front of the screen. So you get a carpet roll, which can build up if you don't put these elevator plates on. So it actually breaks up all the screens that are floating on the wastewater in front of the screen and allows it to be carried up to be discharged. There again, you can just see this cutaway here. So as the flow is coming through the screen and comes through this first panel at the front, the flow can then come through the side, this side, and also the opposite side of the screen and pass downstream, so that all the flow is not just going through this back set of panels as well, because that will reduce or increase the head loss, I should say. We're going to use normally on a 6mm perforated panel, you would have what we call an 8mm pitch. So that's 8mm between the center of each hole. That's the optimum configuration you can have for a 6mm perforated panel. And that usually gives you about 51% open area, which is often specified. And we use a crank link chain as well. So that actually just makes it a little bit more flexible in terms of discharge heights to be able to adjust the screen height and make it easy to remove and replace. And of course, we've got the usual types of spares there, the chain, the plastic seals and everything else. But generally speaking, they're fairly easy to fit, and there's a very low maintenance type of screen. Next type of screen, so we talked about an escalator type screen where you've got the flow just coming into the panels in one direction. this is what we call a Vanguard, so it's a dual flow screen. This orientation is what we call an in-to-out, and I'll explain what that means in a moment. But this usually means that as the flow comes in, you have a channel, you can imagine, down either side of the screen here, and the flow comes into the center and then out through either side of the band. It's blocked off at the back of the screen here, so flow can't go downstream. It has to go either left or right. Well, it goes left and right. So in that instance, all the debris is contained within inside the screen, so there's no carryover at all with this type of screen, which is a key feature. Again, depending upon the width of the channel and the design parameters, we can make this what we call a 4, 5, 6, or 7 or 8 bottom. So that means the number of panels in this D at the bottom can be 4 or up to 8 to increase the width of the screen for a given flow. Usually 2 to 6 millimeter perforations. Again, you can easily replace the inserts, and it gives you a flow range of 80 to 700 liters a second. This, because of the nature of its design, does have a very high capture ratio compared to the escalator type screen, so that's why it's often selected, which gives you 95% compared to 89% for the escalator screen. Again, it has to be tested at Chester Street. There's no brush on this type of screen, so it's just by wash water, and we select the panel thickness, usually a minimum of 9 mil, and that actually prevents what we call hairpinning, so any fibers that are in the flow can get intertwined within the perforations in the panel. If you have a thinner panel section, if you use just 3 millimeters, for example, like on the escalator screen, if you use a thicker panel, actually this tends to prevent this happening compared to a given perforation size, so it means the panels stay cleaner. And then, of course, the wash water just cleans the panels quite effectively that way. Of course, we need a launder spray bar, usually 0.5 liters per second, but it depends on what the flow for the spray nozzles in the screen, depending on the size of the screen. Normally require 3 bar pressure as a minimum, and usually has to be either potable water, or you can use final effluent, provided it's screened to about 500 microns. Again, no submerged parts, so nothing much to wear at the bottom of the screen other than the guide tracks, which are, again, easily replaceable and can be kept in stock. Chain tension, as with this screen and the other screen I mentioned, that we have these screw jacks on either side, so this allows us, the screen wears and the chain does elongate after a while. The screw jacks allow this, by means of this screw here, to lift the drive shaft up, and then tension the chain again, so that you get maximum efficiency and you reduce wear at the bottom because the chain's sagging. And then you can incorporate an integral compactor into this screen as well. So as I mentioned, this is an in-to-out type screen, so the flow is coming down the channel and then passes through both sides of the panel here and then downstream. So, for example, if you're replacing a 1D screen in a channel, I mentioned that 1D screens will pass a higher flow than a 2D screen if you're using an escalator type screen. If you use a band screen, then you can actually pass the same sort of flow as a 1D screen, but the advantage being that you're providing a system that is giving you screening both sides, but also no carryover downstream as well. So that is a key feature. Again, I'll just show you a little video of how this operates. So yeah, because the screen itself can be narrower than, sorry, I'll just start it, narrower than the full width of the channel, we have these wings on the side of the screen at the front there to divert the flow into the center of the screen, as you can see in this video. And the band's rotating in one direction, picking up the debris on the inside, and there's elevating plates on each of the panels there, and combs as well to prevent debris from building up here. And you can see there how the flow passes through either side of the screen. If you wish, you can also put the invert of the channel coincident with the bottom of the inverter here, so that you get flow directly into the screen itself rather than through a step. This shows just the simple sprocket at the top driving the screen chain. and the wash water washing the debris from the outside to the inside this time into a launder in between. Again, panels can be easily replaced. These are ultra high molecular polyethylene, so if they do get damaged, they can be readily removed. Okay. So I've got the panels running in guides, as I mentioned. It shows you there, and you've seen in the video how they can be easily removed and replaced. Spray bar nozzle, we use this fan type pattern here on the nozzles to get the maximum coverage across the full panel width, and then that washes the debris into this internal launder that you can see there. We put the interseal rubbers on and flip wipes on here as well, so that as the band is rotating, it will actually, on this internal launder, if you get any debris that's dropped into this and hanging up on the top here, this flip wipe will encourage it and flip it over, and similarly on the downstream side, it will knock it off the back here as well. So it encourages everything to drop into this launder, which is a key feature of our design. Again, we'd use a crank link chain on the smaller type of screen, which is the 200 pitch chain. Similar profile for the channel, for the perforated plate, and the larger screen, a 300 pitch, or we can do a 450 pitch, again, depending upon the size of the screen. This is more conventional roller type chain. Again, readily available in mild steel, stainless steel, or duplex, of course, that's special order, but we can provide the different materials to suit different applications. Spares, again, similar chains and guide plastics. Excuse me. I mentioned that's the in to out, and then we do what we call an out to in. So again, if you're looking at pumping station applications, for example, or seawater intakes for desalination plants, we would have what we call the out to in there. So the flow actually reverses. Instead of going down the center and through the out thread from the inside, it comes from the outside and then out through the center. So all the screens are captured on the outside there and then washed into this launder at the top. Similar detail to the other type of into out band screen. Flow ranges are similar. No debris carryover because it's all kept on the outside. No brush, and just wash water again for cleaning. And as I said, this shows you how the flow comes from the outside in. So you could have the sea here, or river water intake, or whatever that you're trying to protect your downstream from by screening it. And then the flow comes in and down to the center. Similar sort of construction for the panels, except we don't use usually a perforated plate. We use woven wire mesh. Again, this is stainless steel, readily available, and this can be varying in size from 2 millimeters up to 10 or 20 millimeters, depending on the specification. And a similar type roller chain as well as previously. Some pictures here, the spray bar, which would, for maintenance, really, you need to just make sure that you're checking the spray bar regularly, checking the chain tension, as I mentioned. These are the chain adjusters here, which can be adjusted both sides to lift and tension the chain. Bearings would be lubricated, and this is similar for all types of screens. And then what you do is change the oil on the gearbox every 2 or 3 years. Similar types of spares, again, guide plastics, chains. We do recommend that customers, if the screens are subject to high wear, that they keep guide plastics in stock, and then that obviously allows them to replace those fairly readily. The chains themselves and the woven wire mesh are fairly robust, so they don't need replacing so often. Another type of fine screen here is what we call a drum guard. Now this is not used so often in seawater, sewage applications, but more for river intakes, desalination plants, particularly. You find these a lot in the Middle East. We supplied some to actually a sewage outfall project here in the UK recently for Yorkshire Water. This is what we call a drum guard, so our drum type screen. Probably not the same type of drum screen that you would be familiar with on a sewage works, but this is as an alternative. And again, on pumping stations. Very robust design. It looks a bit like a Ferris wheel or a washing machine drum, and it essentially operates in that way. So water would pass in on the drum screen from both sides, and then out through these panels here and drop down into this outlet channel here. Perforated panels are stainless steel or plastic, again, depending upon the application, different size holes. And we can go from sort of 1 meter diameter up to 18 meters diameter for this type of a system. We can also, there's a spray bar on the top here, which washes the debris from the outside to in, and it drops into this launder, again, to take it away to the screen's handling down this chute. And we can, if necessary, put a brush on there as well, but it's not often we need to do that. Width's up to 4 meters, and there's no, because there's such an efficient sealing system, again, there's no carryover with this type of screen, so you don't get any debris being passed downstream. One thing to bear in mind is it is a quite high capital cost to install this type of screen because of the civil structure required to support not only the screen and the flow, but also the carrier beams for the bearings. They need to be pretty robust to take this weight and load of the screens. But again, all sorts of courses and very robust and excellent screen for particular applications, as I mentioned. So this just shows the kind of elevation here. So you've got the drum guard, the cup type screen, so single entry flow. So the flow comes in here. This is a solid back, and the flow just passes out through the panels at the bottom. And then you've got the dual entry flow again. So that's obviously flow coming from both sides and again down through the bottom there. We can provide fish-friendly types of screen with this particular screen, as we can with Vanguards as well. So we have a system where we have larger elevating trays on the inside of the drum, which capture the fish and keep them retained in some water so that they don't die as they're being passed around. And there's a low pressure spray bar, which as this hopper discharge or gets to a certain angle, will allow the fish to slide into the hopper here and then be carried away to return those into the flow further downstream, so they're not affected by the screen. And then the debris that still remains in the buckets as it's carrying over gets knocked off by a high pressure wash into this separate debris capture hopper here for screens handling. Similar types of things, the spares. The drum screen is actually rotated by a motor which is on the perimeter, and there's a rack and a pinion which goes around the perimeter of the screen. Let's just show you here. So there would be a rack on the outside of the outside diameter here, and a pinion wheel driven by a motor and a shaft, which would then rotate the screen around. And they can be provided as spares. We often provide this. The rack is cast iron and the pinion is a nylon, so that's the sacrificial wearing part, and of course can be readily replaced or kept in stock. And then the usual seals and bearings that would be replaced as well. Of course, for smaller flows and more compact type systems, we can offer the Vanguard compact cleaner. Again, similar applications. Flows 48 litres to 248 litres a second, depending upon the perforated panel that we select, or wedge wire for screening. It's low operating speeds, so low energy consumption, so low maintenance and running costs. You've got the shaftless spiral here, so as the flow comes in, the debris gets collected into the trough here because it's prevented from going down the sides by the rubber on the side here. Any wastewater then passes through the screen, which is at the bottom, into the outlet. There is an overflow should the screen incoming beat the screen's output. And then there's a press head at the top here, which as the screenings are moved up by the spiral to the top, they're then compacted in the top. There's a hinge lid here, which provides the compression on the screen before it's discharged into a skip or other receptacle. Wet screens up to 3 meters cubed an hour, and it gives you a good weight reduction and volume reduction and good dewatering efficiency as well. Because it's a shaftless spiral, as you're probably aware, there's no intermediate bearing, so there's nothing for material to block or collect on, so it makes it a very efficient screen and a reduction in blockages. The other spiral guard channel screen, which effectively doesn't have its self-contained body, but this is then put in a channel, operates in a very similar way, in fact exactly the same way, but this doesn't actually have a means of compacting the screens at the top, so either you get wet screens out of here, or you can then put further screens handling afterwards. Again, similar applications to the other spiral guard, and screening capture ratio is very high as well, up to 75%. The liners are standard Duraflow liner, which is standard across our range for conveyors and this type of equipment. So these are held in stock 1 meter sections, easily replaceable, and they've got this wear indicator here, so that as the red wears down, the spiral's rubbing on because this is actually the bearing surface as well as the means of allowing the debris to be carried up the trough. Once it wears down to the yellow, you can see you've got to think about changing those liners, and then gland packing and the primary screens and various other bits and pieces can be replaced as well, so that you get a fuller functioning screen after a period of time again. So that's the end of the presentation. I hope you found that of interest. Thank you for listening. And if you have any questions, please don't hesitate to ask.
Thank you, Sham. I think I just want to say, you cannot start video because host has stopped it. Okay, interesting. Let's try this again. Anyways, yeah, thank you again for the quick presentation. For anyone, please be sure to type your questions into the Q&A section. I think I probably have a question for you while we're just waiting for our participants to maybe type a question in. So let's say between a moving fine screen and a band screen, right? For example, if I have, so am I getting this right? So I mean, obviously it depends on the channel, which but mostly it's about the screen capture ratio. Of course, channel.
To a certain extent, Peter, yeah. I mean, really, it depends on if you've got an existing works, and for example, if you're trying to replace a 1D screen, which will pass, say, 500 liters a second, because the head loss is lower in a 1D screen than a 2D screen, you'll actually get more flow through that given width of channel. If you try and put a 2D screen in there, an escalator type screen, actually, because you're effectively restricting the flow in the channel because you've got more material in the way, i.e. the panels, because they're now the perforations have reduced the effective open area, you'll get less flow through. So you can't replace readily a 1D screen with a 2D type traveling fine screen. However, you can put in a Vanguard screen so that they then get the flow through both sets of panels, so that will allow you to pass the flow. And we've looked at a few instances in Australia, particularly, where there's a lot of 1D screens there which need replacing because at the end of the service life, and band screen is a good option to replace that. The other features I mentioned, that you don't have the risk of carryover as well downstream. So 1D screens are very good if they're running effectively and kept well maintained. But as we all know, as with anything, unfortunately, maintenance is usually not the foremost the operator's minds, so the things can get left a little bit.
All right, well, I think we have a question. Morten is asking, is the 300 out to in suitable for your municipal wastewater?
It is, I mean, we would normally select the in to out on a wastewater application, just because that's the way that we design it. But if you have a particular installation or an application you want us to look at, then we would happily do that. Is there a reason you want it that way, Morten? Perhaps if I allow you to answer live, then you can answer.
We might just, because we already, I'm a bit concerned about time. We're already over our time. Okay. I'm sure we can, I have Morten's details anyways. We can,
no problem.
Get in contact, and I don't see any other question coming through of now. So we covered all that. So Sham, is there anything else that you want to mention now before we let everyone go?
No, I don't think so. Only to say that if people do need assistance with selecting screens, then we do offer that service. It's not chargeable, so we can advise you on what might be the best type of screen for a particular application, not only our type of screen. If our screen is not suitable, then we would say so and suggest you try something else. But at least we can offer that service there to you to look at the application in the first instance, and then we can help you make a decision if that
sounds good.
Interest.
Great. I think that's pretty much it. Thank you, everyone. We appreciate you being here. Thanks again for joining us today, and we will see you next time.
Okay. Thank you very much. Take care, everybody.
See ya.
Have a good day.
Bye.
Bye for now. Bye-bye.
Take care. Bye-bye.